Hi students, now we move on to exercise 2.2. Question number 1 says find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Now we have 6 sub questions in this question number 1. The first question is x squared minus 2x minus 8. First we have to find out the zeros of this quadratic equation. Let us do that first. For that, you need to find out what are the factors of 8. Minus 8 will have 4 and 2. 4 into 2 gives you 8, and you need to find out by adding what number you get. By adding you get 6, but we want minus 2. For that, you need to have minus sign for 4 plus sign for 2. Now you multiply minus 4 and 2, you get minus 8. And now you add them, you get minus 2. That means we have 4 and 2 as our factors. You have to expand this minus 2x in this form. X squared minus 4x plus 2x plus 8. Right? Now this is our second step. Minus 2x is written by writing 4x and 2x this way. Now we have total 4 terms. 1, 2, 3 and 4. Now we can put the common factors. X is a common factor for the first and second term. The balance is x minus 4. Now we move on to the third and fourth terms. Here we have 2 plus 2 as a common factor. Balance is x. This is not plus, this is minus. X minus 4 plus 2 into minus 4 gives you minus 8. Right? Now, further is x, and this plus 2 becomes 1, and x minus 4 is already there. The meaning of putting this way is we have total one term here, and the second term is after plus. Now out of these two terms, what is common is x minus 4, and then you can put x and plus 2 as the second term. So x plus 2 and x minus 4 will be equal to 0. Now there are only two options to find out the values of x. X plus 2 can be equal to 0, or x minus 4 can be equal to 0. When it is x plus 2 equal to 0, the value of x becomes minus 2. In this case, value of x becomes plus 4, because you take the minus 4 this side, you get plus 4. Now 0, 2 and 4 are the two zeros of x. This is one 0, this is another 0. Now one part of the answering is over. Second part is to verify the relationship between zeros and the coefficients. Now what is the coefficient? The number in front of the variable. For x squared, the number is 1. It is understood. 1 is the coefficient. And for x, minus 2 is the coefficient. And this 8 minus 8 is a constant. Right? Now we are going to verify. Now how do we verify? You know one thing, that sum of the zeros is equal to minus b by a. This must be known to you to answer such questions. Minus b is nothing but minus of coefficient of x, and a is coefficient of x squared. Now sum of zeros, we have two zeros here, minus 2 and plus 4. Let us put that here, minus 2 plus 4. This will be sum of zeros. There is no zero actually. Zeros are nothing but the values of x. This is one value and this is another value. We call them zeros. Is equal to minus b. minus, what is B here? As I said, minus B can be written as minus 2. B is minus 2. You put the bracket, then put the value of B. This minus is this, and B is minus 2. Be careful when you play with zeros or minus signs. Now divided by A. A is the coefficient of x square, which is 1. The next step is simplify this, you get 2. And here RHS, minus into minus gives you plus 2 divided by 1. Further is 2 equals 2. This is one verification. LHS is equal to RHS. We verified that. And the next part of this question we do in the next page. Now the product of zeros. Product of is equal to C by A. What is C? Is a constant. A is the coefficient of x square. Now we know there are two zeros. Minus 2 is 1 0 and 4 is another 0. C is minus 8. Here you can see C is minus 8. Divided by A. A is 1. Minus 2 into 4 gives you minus 8. And in the RHS you have minus 8. So LHS is equal to RHS. We have verified both product of zeros and sum of zeros. They are right. Second question. 4s squared minus 4s plus 1. Now you have to take the coefficient of s square and constant 1. Multiply them. You get 4 into 1. Both are plus. Therefore it is plus 4 into plus 1, which will give you plus 4. Now you have to find out the factors of 4. 2 into 2 gives you 4. But you have to have minus 4. To break this minus 4s, you have to have minus 2 and minus 2. Minus 2 and minus 2 gives you plus 4. And when you add them, you get minus 4. Therefore, you can write this 4s squared minus 2s minus 2s plus 1. Now in this, what is common? 2s is common. Therefore, you can take out 2s minus 1. Here we have only 1 as common. Minus 1. To get minus 2, you have to only have plus 2s. And here you have plus. Therefore, you have to put minus here because minus into minus gives you plus. And then 1. Now 2s minus 1 is common. 2s minus 1. The balance 2s and this minus 1 put together. Now these are the simplified form of the first equation, which will be equal to 0. Now 2s minus 1 is equal to 0 and this 2s minus 1 is equal to 0. In this case, 2s is equal to plus 1 because if you take minus 1 this side becomes plus 1 and s is equal to 1 by 2. It is similarly the same number, so it is s will be equal to my 1 by 2. Now there are two zeros, 1 by 2 and 1 by 2. Now we are going to verify them. How to verify? Let us take sum of zeros, which will be equal to minus b by a. Sum of zeros, 1 by 2 plus 1 by 2 equals minus b. b is minus 4 and a is 4. Of plus of gives you 1 equals minus into minus gives you plus 4 divided by 4. 1 is equal to 4 goes once, so it is equal to 1. 1 is equal to 1. LHS is equal to RHS. This verification is over. The second part of verification is product. Product of zeros is equal to C by A. What is C? The constant term. in the equation, that is 1 here, and a is nothing but the coefficient of s square, that is 4. 1 by 2 into 1 by 2. This is 1 0, this is another 0, and you're going to multiply them to get the product is equal to c, that is plus 1 a 4. 1 by 2 into 1 by 2 gives you 1 by 4 equals 1 by 4. Therefore, LHS is equal to RHS. This verification is also over. Now we are going to the third sub-question of question number 1 of exercise 2.2. The question is 6x squared minus 7x minus 3. Now you have to factorize this. For that you have to take 6 into minus 3 will give you minus 18. Now we have to find out the factors of minus 18 such a way they get you so that you get minus 7. 9 into 2 or 2 factors. Now where do you put minus? You have to put minus to the bigger number so that you get minus 7 here. Now let us write down 6x squared minus 9x plus 2x minus 3. Minus 9x and plus 2x gives you minus 7x. Now we have formed total 4 terms here. Now further, here you have 3 as common factor with x. 3x is common. The balance is 2x minus 3. And this side you have plus 1. 2x. You have to have minus again here. Minus 3. 3x into 2x minus 3 plus 1 into 2x minus 3. Further, in these two terms you have 2x minus 3 as common and 3x plus 1 to be written this way, and this is equal to 0. 2x minus 3 can be equal to 0, or 3x plus 1 will be equal to 0. In this case, 2x is equal to plus 3, therefore x value is 3 by 2. And in this case you have 3x equal to minus 1 plus 1 is taken to the RHS, becomes minus 1, and x value is minus 1 by 3. So there are two now zeros, 3 by 2 and minus 1 by 3. These are the two zeros we have. Now let us go for verification. First verification is by summing them. Sum of zeros, which will be equal to minus b by a. What is b? Coefficient of x term, that is minus 7. And a is the coefficient of x square, that is 6. Sum is 3 by 2 plus of minus 1 by 3. You should be very careful when you have minus signs. So put brackets so that you don't mess up things. This is sum, so therefore it should be added with the plus mark. But for 1 you have minus. So to be very careful to put a bracket. Now equal to minus b. Again put minus. Now write down what is b. b is minus 7. Again be careful. Open a bracket, put minus 7 and then close it so that you don't go wrong. Divided by a. In this case a is 6. Now simplify. 3 by 2 plus into minus is minus 1 by 3 equals minus into minus plus 7 divided by 6. Here this is LHS. You have 2 and 3 in the denominator. Take the LCM, that becomes 6. 2 3 is 6. 3 into 3 is 9. Minus this minus is here. 3 into 2 becomes 6. 2 into 1 is 2 equals 7 by 6 as it is. 9 minus 2 is 7 upon 6 in the LHS. 7 by 6 in the RHS. Therefore, LHS and RHS both are same. It is verified. Now we are going to continue the second part, that is verification by using product of zeros, that we do in the next page. Now we have the product of zeros, which will be equal to C by A, and the zeros were minus 1 by 3 and 3 by 2. These were the two zeros. We are going to find the product of zeros, which should be equal to C. C was minus 3 in the equation, and A is 6. Minus 3 by 6. When you simplify this, you get minus 3 on the top. 3 into 2 is 6 in the denominator. It will be equal to minus 3 by 6. LHS is equal to RHS. This is verification by product of zeros. Fourth sub question, which is 4u square plus 8u plus 0. Now you have to simplify this. 4u into u plus 2 plus 0. Now 4u can be equal to 0, or u plus 2 can be 0. Therefore u is equal to 0 by 4, which is equal to 0. One value of u is 0. Here u is equal to minus 2. This is another value, or two zeros of u, 0 and minus 2. Now we are going to verify them. How to verify? First is sum of zeros. Let us write down this here. The value of b and a can be had from this equation. Now we know there are two zeros of this equation. One is 0 itself, plus other one is minus 2. Put the bracket, then write down minus 2. And this side in the RHS you have minus b. What is b? B is coefficient of u, that is 8. And in the denominator you have a. A is nothing but the coefficient of u square, that is 4. Now plus into minus is minus 2 equals minus 8 by 4 will give you minus 2. 4 into 2. So you get minus 2 in the LHS and minus 2 in the RHS. This is how you can verify sum of zeros. And the second part of verification is product of zeros, which is equal to C by A. Product is again 0 into minus 2. This is one value of u, and this is second value of u. Two zeros of u equals C. C is a constant. Here we have only 0 here. And A is coefficient of u square, which is 4. If you divide 0 by any number, you get only 0 here. And when you multiply any number with 0, also is 0. 0 is equal to 0. LHS is equal to RHS. So we have done the verification of this equation 4u square plus a2 plus 0. We are going to attend fifth sub question in question number 1 of exercise 2.2. The question is t square minus 15. Now our duty is to find the zeros of this equation and verify with zeros and coefficients. So first let us start taking the zeros of this equation. T square minus 15, if you write down, it becomes a little difficult to solve. What we do, we make this root 15 and then square this. By taking root and then squaring this, the value of the given equation doesn't change. Now this is in the form of a square minus b square, which is equal to a plus b into a minus b. T is in the place of a and root 15 is in the place of b. Now when we expand this, you get t plus root 15 into t minus root 15. Now t plus root 15 is equal to 0, or t minus root 15 is equal to 0. In the first case, the value of t is minus root 15, because if you take plus root 15 to the RHS, it takes the sign of minus. This side, the value of t is equal to plus root 15. By taking minus root 15 to RHS, thus you get plus root 15. Now minus root 15 and plus root 15, the two zeros of this equation. Now we have to start verification. Sum of zeros is equal to minus b by a. B is nothing but coefficient of term t in the equation, and a is the coefficient of t square. We have coefficient of t square a, but we don't have b. For that sake, we will make a small change here. The same question can be written as t square plus 0 into t, then put minus 15. By introducing 0 into t becomes 0, thus the equation value doesn't alter. Now we got b, which is coefficient of t, which is 0. Let us write down here. Sum of zeros, we have plus root 15, then plus minus root 15 is equal to minus b. But b value is 0. Therefore, we don't write minus. We put 0 upon a. A is 1. This 1 is coefficient of t square. When you simplify this, you get root 15 plus into minus minus root 15. And this is equal to 0. One thing you have to remember, 0 doesn't take either minus or plus. It is independent of the signs. Therefore, don't put minus or plus in front of 0. When we divide 0 by any number, we get 0. Thus, 0 is equal to 0. LHS is equal to RHS. This is one verification. Second verification is product of zeros. It is C by A. Let us put zeros of the equation, that is root 15 into minus of root 15, which is equal to C, which is constant. Constant is minus 15 upon A. A is 1. Now this is equal to, when you multiply a number with squares, that becomes the number itself. But here we have minus, therefore it takes the minus sign, and 15 is the answer here, and equal to minus 15. LHS is equal to RHS. This is second verification. Now we have solved the fifth sub question, and let us move on to the sixth one. 3x squared minus x minus 4. This is the sixth question and the last question in question number 1. How to solve this? We need to first take out the zeros of this equation. Zeros of this equation can be had when we factorize. To take out factors, first we need to find out whether we can multiply 3 and 4. Minus 4 into 3 will give you minus 12. Now we have to find out the factors such that you get minus 1. For that, we know factors of 12 are 4 and 3. 4 into 3 gives you 12. But you have to put minus in front of 4 or in front of 3. Now that you have to decide looking at minus x. You need to have minus 4. Only then you can get minus x. Now let us write down 3x squared minus 4x plus 3x minus 4. This is equal to the first equation itself. Now we have x as common factor. The balance is 3x minus 4 plus 1, again 3x. To get minus, you need to put minus here and then put 4. Thus you have x plus 1 as one term, 3x minus 4 as the other, which will be equal to 0. Now x plus 1 is equal to 0, or 3x minus 4 is equal to 0. If x plus 1 is 0, the value of x is minus 1, because you take plus 1 to the RHS. In this case, 3x equals minus 4 becomes plus 4, and x is equal to 4 by 3. Now we have found out values of zeros. One zero is minus 1 and the one is 4 by 3. Now the second part of the solution is verification. We do that by sum of zeros is equal to minus b by a, and let us put the zeros here first. Minus 1 plus 4 by 3 is equal to minus b. What is b here? B is 1, that is minus 1 upon a. A is 3, which is coefficient of x squared. Now when we simplify this, you get 4 by 3 minus 1. This we can rewrite 4 by 3 minus 1, which will be equal to minus into minus is 1 by 3. This side, LHS, take out the LCM, which is 3 upon 4 minus 3. 3 1 to 3, 1 into 4 is 4, minus put as it is. In here below we don't have anything, so we have only 1. 1, 3 is a 3, and 3 1 is a 3. This is how we have to simplify, which will be equal to 1 by 3. 4 minus 1, 4 minus 3 is 1 upon 3 in the LHS, and 1 by 3 in the RHS. Both are equal, so first verification is over. For the second verification, we can write down here product of zeros, which is equal to C by A. The zeros are minus 1 into 4 by 3 equal to C. C is minus 4, the constant term, minus 4 upon A. A is 3, which is coefficient of x square. When you simplify this, you get minus 4 upon 3. In the RHS, you get minus 4 by 3. LHS is equal to RHS. This is second verification. We have completed all the questions of question number 1 in exercise 2.2. Now the students, please find out the question 2, which says find a quadratic polynomial each with given numbers as the sum and product of its zeros respectively. This is in exercise 2.2, and in this question 2 we have total 6 sub-questions. In the previous cases, the equation was given, that is quadratic polynomials were given, and we were asked to find out the zeros and then verify also. But in this question, they have given us the zeros, and now they want us to find out the quadratic polynomial in each case. The first question is 1 by 4 and other one is minus 1. 1 by 4 is itself sum of zeros, and minus 1 is product of zeros. And we know very well the sum of zeros is equal to minus b by a. And we write down sum of zeros, which is 1 by 4, which is equal to minus b by a. Now the value of b, that is minus b, is equal to 1, or b is equal to minus 1. We shift minus to the other side, and a is equal to 4. These are the two values of b and a. And product of zeros equals c by a. And this is minus 1. And in the denominator you don't have anything, so put 1 is equal to c by a. And minus 1 is in place of c, and 1 is in place of a. Therefore, c's value is equal to minus 1. A value is 1. Now you can see that the value of a is 4 as well as 1. When we have these two different values of a, you cannot form the quadratic equation for the given question. Therefore, you have to equal them. How do we do that? Here, minus 1 by 1, you can multiply 4 so that you get value of a as 4. Minus 1 by 1 into 4, both to the numerator and to the denominator, which will be minus 4 upon 4. That means which is equal to c by a. Now the value of c is equal to minus 4 and value of a is 4. See, this is a and this is c. Now this value is invalid. Now you have to take these two values. Now in summary, we have a which is equal to 4, b is equal to minus 1, and c equals minus 4. Now these are the values of a, b and c. With this we can form the quadratic equation. We know very well the general form is ax square plus bx plus c. This is the quadratic polynomial. Now we know the value of a, which is 4. So put 4 and then x square, put plus as it is. B, here it is minus 1. Put minus 1 and then put x as it is, plus 6 plus c. C is minus 4. Whenever you have plus or minus, please ensure that you put brackets so that you get the correct answer. Now it is equal to 4x square, plus into minus is minus x, and again plus into minus, minus 4. Now this is the equation required for us. Now we move on to the second question. Now the second question is root 2 and 1 by 3. Now root 2 is the sum of zeros, which is equal to minus b by a. Root 2 is equal to minus b by a. Root 2 is the sum of zeros as per the question. That's what we have written here. In the denominator, you don't have anything, so put 1. Here, the value of minus b is equal to root 2, or b is equal to minus root 2. Then a is having 1 as value. These are the two values of a and b. Now we move on to product of zeros, which will be equal to c by a. And we know in the question product of zeros is 1 by 3. Let us write down that 1 by 3 is equal to c by a. C is 1, a is 3. C is 1, a is 3. Here again we have the same problem, that the a has two values, 1 and 3. You need to multiply 3 to root 2 by 1 so that you get a value as 3. Let us write down that root 2 by 1 into 3 by 3 is equal to 3 root 2 upon 3. This is minus b by a, that is this one. Here we took minus b by a, which is equal to root 2 by 1, and we multiplied 3 to the numerator as well to the denominator, and we got this. Thereby, a value becomes 3 in both the cases. You can see this is now invalid. We have minus b equal to 3 root 2 and a equal to 3. In this case, b is equal to minus 3 by 3 root 2. This is one value of b and this is a value. And finally, you have a 3, b is equal to minus 3 root 2 and c is equal to 1. So we have three values. Now we can form the equation, which is general form is x square plus bx plus c, and in place of a you have 3x square plus b is minus 3 root 2 into x plus c is 1. Now this is equal to 3x square plus into minus is minus 3 root 2 into x plus 1. So this is the quadratic polynomial to the question number 2. So we move on to the third question. Third question is 0 and root 5. Here we know the sum of zeros is equal to minus b by a, which is 0 equals minus b by a. Now we don't have anything in the denominator, so you can put 1. By putting 1, the value of 0 remains 0 only. Now the value of b, that is minus b, is equal to 0, or b is again 0. As I said, if you even transfer minus this side, 0 doesn't accept it, so b value is 0 and a value is 1. These are two values we have, and then we go on to product of zeros, which is equal to c by a. In the question, root 5 is the product of zeros, which is equal to c by a. In the denominator, you don't have anything, put 1. Thus, the value of c becomes root 5 and value of a becomes 1. We have 1 as a value, and here also we have 1 as a value. So we can form the quadratic polynomial. Let us write down the standard format, that is ax square plus bx plus c. This is the standard and general form of quadratic polynomial. In place of a you have 1, that is equal to 1 x square plus b value is 0 into x plus c is root 5. Now simplify, you get x square plus 0 plus root 15. Now this need not be written, so we simplify further, x square plus root 15. This is the quadratic polynomial of this question. Now we move on to the fourth question. The fourth question is 1 and 1. Fourth is 1 and 1. That means 1 is sum of zeros and 1 is product of zeros. Let us write down that. Minus b by a. 1 upon 1 is equal to minus b by a. Why we wrote 1 here? To find the value of a. Now minus b is equal to 1, or b is equal to minus 1, and a is equal to 1. See, this is in place of a and this is in place of minus b. Right? Now these are the two values we have. Similarly, we move on to product of zeros, which is equal to c by a. And this is also 1. And in the denominator, you can write down 1 as it is and write down c by a in the RHS. Now, in place of c you have 1 and in place of a you have 1. Therefore, the value of c is equal to 1, a is also 1. These are the values. You can see that value of a is 1 in the first case and it is again 1 in the second case. Therefore, you can now form the quadratic polynomial, which is ax square plus bx plus c, and this is the general form. And now you substitute the values of a, b, c. You get a is 1 x square plus b. You have minus sign, therefore you put bracket into x plus c. C is 1. Now simplify, you get x square plus into minus c is minus x plus 1. Now this is the quadratic polynomial of this question. Now we move on to sub question 5. The fifth question is minus 1 by 4 and 1 by 4. Sum of zeros is equal to minus b by a. Here minus 1 by 4 is sum of zeros. Let us write down that minus 1 by 4 is equal to minus b by a. Now what is b value here? B value will be, let us write down that minus b is equal to minus 1 or b is equal to 1. You can cancel minus and minus either side. Then b value will be equal to 1 and a has the value of 4. Write down that a is equal to 4. Now these are the values of a and b. Now let us write down the product of zeros, which is equal to c by a. And in the question, product of zeros is given 1 by 4. 1 by 4 is equal to c by a. Therefore, c is equal to 1 and a is equal to 4. That means 1 is in place of c and 4 in place of a. That's how you got value of c and a. Here you can observe that a value is 4 in both the cases. Therefore, you can now straight away go to the formation of the quadratic polynomial. That we know a x square plus bx plus c is the form, and now substitute the values of all a, b, c in this equation. A is 4. Put 4x square plus b. B is 1. 1 into x plus c is again 1. Simplify this, you get 4x square plus x plus 1. So this is the quadratic equation of the question. Now we move on to the last question, which is sixth question. Sixth question is 4 and 1. Sum of zeros is equal to minus b by a. And we know sum of zeros is nothing but 4 equals minus b by a. In the denominator you don't have anything, so put 1. And now we know the value of minus b is equal to 4 or b is equal to minus 4. That is, minus is transferred to the RHS. So b takes the value of minus 4 and a is equal to 1. Now go to the product of zeros. We know that it is equal to c by a. Now 1 is the product of zeros. Write down that 1 upon 1. When we don't have anything in the denominator, put 1. That is equal to c by a. C is equal to 1. A is equal to 1. C is equal to 1. A is equal to 1. That means now the value of a in both the cases is 1. Therefore, you can now go for the formation of the quadratic polynomial, which is ax square plus bx plus c. In place of a, you have 1 into x square plus b is minus 4. As I said, put the bracket so that you don't go wrong. Into x plus c. C is 1. Simplify now. X square plus into minus is minus 4x plus 1. So this is the quadratic polynomial for this question. Now, boys, we have completed question number 2 of 2.2. With this, exercise 2.2 is over. We will do the exercise 2.3 in the next video.